This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers.
Welcome to the Art of Network Engineering, where we talk the tech, live the journey, and occasionally meet in real life to share a few beers. Speaking of beers in real life, I have Dan Richards with me this evening. Dan, how are you, my friend?
Howdy, Tim. I'm doing great. How about yourself?
I'm doing well. I'm not used to not seeing you in person after Asheville recently, so...
Yeah, it definitely is different, right? Like after we, had a show in person and like I could look over and see you, sitting beside me. I don't like this anymore. I don't like the whole like being,
we've been spoiled.
It was oh yeah. Well, and I'll tell you, like, one thing I didn't realize, like, when we were in person is, we can read the body language better. And so we really didn't step over each other or anything like that. It was just one of those things where you're there, you can kind of see when someone's ready to say something and you just back off kind of thing.
Yeah, there were no delays in person, and that really showed, I think, because I didn't even think about it until after that first one we recorded, we got done. It's like, whoa, I don't think we stepped on anybody in that entire time. So.
Yeah.
Hey, it just means we got to have goals to be able to do this full time in person someday, right?
Yeah, right. That'll be a while.
Yeah, probably. All right, Dan, let's get into it. This is a sponsored episode from Netris, and we have Alex Saroyan. Alex is the CEO and co-founder of Netris. Alex, thank you for joining us. How are you this evening?
Hi, guys. Thanks for having me. Good to see you. I'm doing well.
We're doing good. We are so glad that you are joining us.
Yeah. So, Alex, we said you're the CEO, right, and the founder. What is Netris, though? Can you give us a little bit of a background on what that actually is right now?
So Netris is software that runs your data center network automatically. So basically, Netris configures your switches, your routers automatically, providing users with a cloud-like user experience. Like in public cloud, you have this thing called VPC that is running your everything related to your network. That's the direction that we're going, and eventually Netris will be the VPC for your on-prem private cloud.
I think that's a really interesting stance. You're kind of taking the standpoint that in the cloud, people can easily click buttons, start applications. They don't necessarily have to worry as much about the back-end infrastructure. It's built for them automatically, but maybe public and some private clouds aren't for everyone. So you're giving people the ability to have that cloud-like experience in their own private cloud data centers. Does that sound about right?
Yeah, absolutely. We try to think about cloud and Kubernetes, not just about technologies, but also kind of new kind of expectation of infrastructure practitioners. You deploy your applications in Kubernetes and it's live immediately. You don't need to wait until Unix engineers will make it work. That's kind of becoming de facto norm expectation. And the same is happening with the infrastructure. When you want to, let's say you want to launch a test cluster of Kubernetes, or you just want to launch a bunch of virtual machines to run some tests, you create a new VPC, call it test whatever, drop a couple of VMs into that, and it's up and running. You start your testing. You don't need to worry about implementation details. You don't need to worry about, you don't need to wait for anything. So it's all about making resources and applications ready for the engineers immediately.
And security, what about security? It's super secure, right? Right out of the box.
That's a good question. Actually, when things are done automatically, lot of things can be done kind of according to best practices or according to security policies, things like that. Like oftentimes, what becomes what creates security problem is because someone forgot to configure something. So when things are done automatically, there is no this risk. We humans, we are great on planning things, on architecting things, but when it comes to like doing things many times, we don't like that. We're kind of lazy. We'd rather architect software and technology and make software and technology do that kind of repetitive things for us, and therefore we can even increase the security with that kind of approach.
I was kind of thinking more along the line of like the cloud approach, right? I feel like sometimes clouds are made to be very simple, throw things together, but then they kind of lack on security side. And so I was just curious if does Netris keep that in mind whenever because your product's almost drag and drop, right?
Correct. There's a lot of so our product has graphical user interface where you can drag and drop draw your topology, for example, if that's network engineer using Netris. Remember back in days, network engineers would draw a topology and architecture using whiteboard and would think how to translate that into configuration. And of course, there are many ways to cut the orange, but in case of Netris, the idea is that network engineers would draw the desired architecture. They would say, these are my switches, these are my routers, these are connections with my upstream provider, things like that. They will provide the information which is architectural kind of information, just like they would draw on whiteboard. And all that drawing inside Netris, that turns into objects in Netris database that Netris algorithm will turn into actual configuration. Now, coming to the security question, so when Netris algorithm translates that architectural drawing into configuration, there's like a lot of layers of analysis that's happening as a part of algorithm. So the algorithm will not forget to configure something, will not forget to, like, for example, set echo to make sure your SSH is not closed from outside, is not open from outside the world. We'll make sure, like, for example, just an example, let's say you're connecting with your upstream provider, and like what happened to me when I was engineer many times, like you plug in, you configure a BGP upstream with the internet provider, and your BGP port is, accessible from outside the world, and that's not like super critically dangerous, but like it's a potentially room for a SymFlood attack that that can be negative for the CPU of your router. Things like this happen all the time, but when configuration is generated by algorithm kind of will not forget to configure that ACL. It will open only for the IP address of the upstream, not for the world. So from that perspective, that's
anything
that's
that can help me
security.
not to forget things is going to be incredibly helpful. I really appreciate that approach, because anytime that you can create policy and have some sort of software or script to be able to constantly check and enforce that, I think is really important, because especially when you have multiple staff, multiple engineers that are physically configuring devices, I may have my standard, Dan may have his standard, AJ, Andy, all of us may do things, it's going to be fairly similar, but we're going to have that configuration drift over time. So anything that can be in place that can keep us in check, I think is really important. So Alex, I think we're having some great conversation about Netris already, but what we focus on here a lot is people's stories, people's journeys, and how you got to where you were. Now, you can correct me, but I'm going to guess you haven't been creating companies since day one of your career. So can you kind of talk about how you got into Netris and how you got into doing what you're doing now? Do you have a network engineering background?
Yeah, that's absolutely true. I've started as a network engineer. I just loved technology since my childhood, since I was in first grade, somewhat. And after high school, I got into network engineering. I started working as a network engineer for a little ISP that I happened to co-found.
He did correct me. That was probably the nicest way somebody could correct me too. Just nicely, gently into it. That's excellent. So you hold on. You co-founded the first place that you started your technical career?
Yeah, but there was a small ISP, not a venture funded business, but just a small ISP. I started from sharing my internet connection with my neighbors, and then I've got the entire neighborhood, becoming my kind of users, and I thought why don't I turn this into kind of business? I'm having fun doing this, and kind of it could help me to keep my lights on. And over a year or so, my room became like a little data center, and my parents were not entirely happy with the sound of spinning fans, and then I ended up kind of renting a little data center room and moving the equipment there. Yeah, that was really small one, and that was we went through a tiny acquisition, and after that I decided it's kind of time to get an actual job, and
well.
I got into this company.
Yeah, I do remember that.
I remember Google search and email before Google. I've joined their team as an engineer. I kind of knew engineering, but joining Lycos was entering team which I didn't co-found, and becoming part of bigger group of professionals and learning from them. Solving new problems for different company and learning from other people in that company. That was very kind of start of my more professional.
Yeah, because running a data center out of your room isn't professional, huh?
that was more of a hobby, which just happened to make a little bit of money for me. Like I happened to buy my first car myself.
That's nice.
That was kind of.
I just want to know, like, did your parents, were they like, WTF, like, what is this power bill? Like,
yeah, there was I started paying the power bills because like that could be an issue. But you know, the noise from the servers, that was.
I guess you guys didn't have to pay a heat bill, did you? Yeah.
No,
you had a room full of heaters.
So during this time, and so pre-Lycos, did you have any formal IT or network engineering training, or were you learning this all as you went and teaching yourself?
Just teaching myself, just, you know, reading everything around Linux, you know, searching for information on internet, like reading books, and my very close friend of my father, he happened to be a network engineer, like one of these first early network engineers, and he helped me a lot. Like I remember when I was a kid, like in third, fourth grade, and I would love when my father was taking me with him to visit his friend, and I was asking him about computers, about Linux, and I remember one day he kind of explained, I asked him like how this internet thing works, and he explained me how routing works, and he explained that really super simple. Like how would you explain routing to a kid? And that was it. I was like, I wanna be network engineer. I wanna build the internet. I wanna be part of the internet. This is so amazing. Like this is something big that everyone can be part of it. That's how I kind of got into network engineering.
So you brought the internet to your house.
Made your house the internet. Yep.
Yeah.
Yeah, and started sharing with neighbors, and it was like, how do I learn? Who would trust me a network to learn on it? Well, I gonna build
So let
one.
me ask you this: did your upstream provider know what you were doing? Like,
no, and my very first upstream provider was like 56K dial-up modem connection, and then when I've connected a bunch of neighbors, I figured that's not enough, so I have connected the second 56K, and they were like connected in load balancing mode, and a few times they emailed me like that's weird, like you keep your connections constantly, you know, under load. And over some time I discovered, like back then it was a thing, like this downstream only, you know, satellite kind of internet access where you put the you know, satellite antenna, and you're using it just for downstream, and you use your dial-up for upstream. So that was kind of, for me as an you know, as a junior engineer, it was very kind of appealing to me. It's like, wow, this is kind of cool. I send data out one channel and I receive through another channel and a bigger channel. So that's how I did. It was interesting and beneficial because, you know, you don't need a lot of uplink connection, but you need more downlink connection. So two 56Ks were like about 100K upstream together, and I was getting like almost a megabit of downstream, and back then that was huge. And somehow I got the kind of fastest internet connection, fastest and cheapest internet connection in the neighborhood, and I don't know. That's how I started kind of scaling.
I really think that's
very
I think that's a
interesting.
common trend that we hear, and I know that I personally felt the same way about networking, because when I went to school, I tried the calculus and the C++ and all that, and it was hard for me to grasp. And I felt like I had to constantly be working at it every day. And then I sat in a Cisco Netacad class, and it, like you said, those first concepts really just hit and stuck. And I'm not saying, networking is easy by any means, but a lot of you can follow the OSI stack from 1 to 7, and concepts are easy to modularly put together, and I think that's what really sticks with people, because you can get as in depth as you want, and I think that people need to understand, once you get into networking, you run the highway for all the applications and all the services, and you will quickly learn high level concepts about what everybody else is doing too, and you become incredibly valuable as a technology person getting into networking. So I'm really glad you highlighted that. So from Lycos, what took you from there?
I was just looking for a job in a kind of bigger company, because what I did with my hobby type internet service provider thing, I've learned a lot, that was fun, it fulfilled my curiosity, but I was thinking I want to become kind of more professional, like how I want to learn how other people work, like how do they do this in bigger companies at bigger scale, like how do they run these huge data centers. That's how and why I got into Lycos. That was a lot of learning. Everything was so new, like this culture was very back then they had almost like a startup culture. Like from one side they were pretty much systematized in terms of like they had documentation of their infrastructure, they had processes, they were using like internal ticketing systems. All that was kind of very new for me, because running this tiny ISP, you can imagine we didn't have all that process, right? So I've learned that, and there were kind of my first steps in kind of being part of an enterprise, larger company. I've been there for a little over a year, and then I went to another company, which was Orange France Telecom. Actually, I've joined them, and they had the project of launching a new operator, and somehow I happened to become part of that project and participated in that, designing a bigger, telco data center and rolling that out, which was again a lot of learning.
So at what point, as we kind of start to tie this back together to Netris and what you're doing there, at what point did you start seeing kind of the vision for Netris and what you're doing?
So when I was working on this project of launching, architecting, designing, and launching these data centers for Orange, I happened to work in the same room with my co-founder of Netris, and we've been staying until late night, working on something, because there was a lot of work to do and a lot of learning for us. So we were kind of figuring out things together, experimenting, trying. And that's kind of where the idea started to kind of born. And we were not thinking back then to launch a company, but like we've started asking each other these questions that were kind of bugging us. One question was that, every time someone from other teams, they required something, like let's say database administrator team, they would need a new segment, a new VLAN, a new bunch of servers. That would require them to come to us, networking team, to say, hey, networking team, could you provide us more ports, more VLAN, more IP addresses? Can you, and then we would ask them, create a ticket, we would provide, like that life cycle was taking time. And we were networking team, and of course we were like, hey, why would you need access from this IP to that IP? How come cannot do more with less access? Like, that's not secure. Things like that, like things that all, many network engineers would like to do. And that was part of the company's policy, because they had like the policy, like network engineers and a whole bunch of others would need to approve things and would need to stick to these policies. But thing that was bugging me, it was that like this is not efficient, like this is taking time. Every time people need to make communication happen from here to there, like they need to go to this, levels of bureaucracy and engineering and implementation. And we all know, right, that that's never seamless. You implement something, you break things, you make mistakes, and especially when there's more than one engineer thinks one way, another engineer thinks another way, and there's many ways to cut orange. So these things create conflicts over time, and sometimes you just blow up the network. That happens. So it was bugging me. Like, okay, this is how people do networking, but there should be like projecting that to growth of the world. I was like, geez, like if we do networking like this all the time, our humanity cannot scale. Like we're gonna need more and more networks. And if we look at the graph of number of network elements, growth, and number of network engineers that we produce, like we're not gonna make it. There's no way. Network engineers can become like a bottleneck of growth of humanity. We need better technologies here.
Yeah, I definitely agree with that. There does seem to be a point that you hit in certain organizations or certain size of organizations where at some point the network team does seem to be, we're involved, like I said earlier, we're the highway. So we have to be involved in many projects and many conversations. And at some point when so many different people need so many different things, and we have to do these very conversational chats with, okay, what do you need? Why do you need it every time? And then, okay, I need X amount of time to be able to build that because I've got 3 projects in front of you. Yeah, at some point we need to lean on technology to help us. So yeah, that's really interesting insight that you came up with, that just kind of organically chatting with somebody that you were working with over time.
Yeah, to add to that, so like when I first started, our time to market, or whatever you want to say, our SLA on a request was like, depending on what it was, is roughly 2 weeks, right? And so we were given 2 weeks to, implement a server or make some kind of network change kind of thing. But over time, it's like, especially now, it seems like if it's 2 days, that's 2 days too long, and kind of like what you're saying is, when people start putting that pressure on, I feel like sometimes I can get sloppy with what I'm putting in because I'm just in a rush trying to get it in place. And then I make a mistake. And then now it takes more time because now we have to troubleshoot it with, a developer or whoever put the request in. And it takes time, right? To fix it, to figure out what the problem might have been, kind of thing. So I definitely see what you're saying there in having, some kind of, we talk about automation on here every once in a while, and that's kind of like the track that I'm going down right now is trying to figure out how to integrate either Python or Ansible or both into, and the way I'm looking at automation is not to do a bunch of things like super repetitive. I mean, I do want to do repetitive things or put repetitive things through automation. But what I'm really looking forward to is doing it the same way every single time and not having mistakes whenever I push that button, right? And so I can definitely see your concern with how much network changes are coming through, and then how few of the engineers we actually have.
Yeah, Dan, I think we as network engineering and operations teams, we can either be seen as a value add to the business or as a roadblock and a cost center. And at some point, we're humans and we need processes and things that can help us with those daily tasks to be able to provide that value to the business quickly and like you said, efficiently, because if it's not right the first time, then you got to take more time to do it again. And who knows what else you broke by doing it wrong the first time. So definitely.
Oh yeah. 100%.
So at what point, Alex, did building a company around this idea start to come to fruition? At what point did you decide, okay, we have to do something about this, and starting a company is the right way to do it?
So back then, just like Dan said, I started looking into automation. I started looking into how, just basically from the perspective of how can I do my work better? That's it. I was not thinking about starting a company back then, and but by then I moved to another job, and my co-founder and I, we ended up working for different employers. But I was a network engineer still, running a team of network engineers there, and it was still bugging me. I've tried to experiment. Started experimenting with traditional ways to automate, writing scripts or using different libraries where you can kind of try to automate repetitive tasks and kind of come up with a template, give that template to some sort of script, and it will kind of configure something for you. And to me, I remember there was a guy working in our room. He loved to use this analogy between network engineer and nuclear physicist. He's saying, what is common between network engineer and nuclear physicist? The common is when each of them are saying, oops, the impact can be huge.
So I'm going to use that. That is
so. That happened to me a couple of times. I did oops, and an entire country experienced a blackout for a few minutes, and it takes time until you realize what happened, you troubleshoot, you kind of bring things back, right? And when I was playing with the different approaches to automate network engineering tasks, what I've discovered, I felt like there's a conceptual problem. placing an automation thing between human and CLI, that's like an amplifier. If you make an oops as an input of that amplifier, you just increase the, you make it like disastrous failure. And so I figured, no, this is like, there's conceptual problem. There should be a different, I should not be in charge of deciding what commands to send into CLI. That should be on someone else, because me as a human, I'm good on figuring out the architecture, the high level things, what I want to do, but how to do, this is the part where I'm having trouble sometimes, not always. Especially when I'm getting good on something, I'm becoming confident, and this is when I make the oops. So I figured it's not like, it's fundamentally kind of not scalable to trust, to assume that human will not make mistake. That's how I came to the idea that no, there should be a layer of software which kind of is not, it's not linear, it takes something on input, it has ability to understand that input and ability to generate the output. So the generation of output should be done by kind of properly developed software. Test it 1 million times software, test it in many different scenarios software, yes. Software that is following best practices, but like software, not human. That was kind of the idea, which was, that was kind of where my head was back then. And public cloud was, growing, and I think Kubernetes was just starting back then, but public cloud, it was, I could already tell that public cloud is going to be big. And public cloud kind of was the first technology that is sort of opinionated in terms of implementation. It was the first technology where you say, I want this. I want this service to communicate with that service, and I don't care what kind of black magic is happening under the hood. I just trust them. I don't care if they use protocol X or protocol Y or OSPF or BGP, whatever makes it work, it's fine. So I figured, man, it's okay to use an opinionated system, because that system takes away the risk of oops. That's kind of where the core building blocks of idea came in, and then I've called my friend, now co-founder, and I told him like, hey, look, we're gonna build this. Remember, we were speaking, in front of the building by night when we were building these networks. Like, here's the idea. I have created little prototype. It kind of shows some tiny signs of potential work. Like, let's do it. Are you in or out? He said, I'm definitely in. So that's how we started. Just put together a little prototype, and we said, like, if we can find someone who can say that this makes sense, I'm gonna use in my production. If it works, I'm gonna use in my production network. Maybe it's viable. We should work on it. That's kind of how it started.
So one thing I want to kind of go back on is you're talking about how cloud is, did you say opinionated?
Yeah, opinionated and self-operating. Like when you ask cloud to provide connectivity, when you say, "Hey cloud, give me a VPC and give me 25 VMs inside this VPC," you don't know what kind of technology is working underneath. Is there a VXLAN? Is there a BGP, VPN? Is there a VLAN? Is there whatever is working there? You even don't have visibility into that. You don't have a control, because that's kind of up to technology to make that work, right? That's kind of higher level of abstraction. Traditional networking has like low level of abstraction. Cloud and VPC in the cloud has a higher level of abstraction. And that level of abstraction is very similar to Kubernetes.
Because you essentially don't care, which container does what, as long as it's servicing whatever the need is, right?
Yeah, exactly. What Kubernetes did to compute and application provisioning, the same VPC does to cloud networking. And the same is, we hope, Netris does to physical on-prem networking. You're still gonna need network engineers, NetOps engineers to tell Netris what to achieve, what architecture we're looking for, how do we plug in our upstream providers, things like that. But the implementation of configuring protocols and timers and things like that is done automatically by software. So that helps to avoid human mistakes from one side, that enables network engineers to provide solutions that DevOps engineers of today that are accustomed to public cloud. So network engineers, with the help of this kind of products, are able to provide kind of right products for today's DevOps engineers. Today, just like you said, the ticket implementation time was like days or weeks. Like that's not acceptable in today's public cloud world. You create a VPC, you throw a bunch of VMs, and it's ready to operate. It's under 1 minute. It's not even hours. It's just 1 minute, and that's what DevOps engineers want to see. That's what DevOps engineers expect from network engineers
today. I get frustrated when it does take a minute.
Yeah. So Alex, you mentioned on-premises data centers. Can you kind of unpack a little bit more, like who directly is the target audience for the Netris product? Is it medium to large size companies and infrastructures that run their own data centers, where maybe public cloud for whatever operational or compliance reasons isn't the right fit and they need to do it on premises? Who's the target audience here?
Great question. So from one side, public cloud kind of defined the new expectations in terms of user experience, DevOps, NetOps type of user experience. But from another, and that's great. That is, helping humanity to move forward. While public cloud is not one size fits all kind of solution for some use cases, it's just expensive. It's prohibitively expensive for some use cases, especially for late stage companies. For early stage companies, public cloud is amazing place. Early stage companies don't care about cost. They only care about being fast and innovating fast and engineering their products for obtaining growth. But for late stage companies, cost efficiency is becoming important when these companies are preparing for IPO or acquisition, because there comes the economics of the company, and they want sometimes they see that, geez, we have very high revenues, but like high percentage of revenue is the cost of our infrastructure. So for these companies, it's a way to reduce the costs in order to increase their market capitalization. That's just one case. Besides that, there are cases where like applications are latency sensitive, especially all kinds of VR and AI applications. And that creates the use case for the edge, right? You want to move your workloads closer to your users. And that can be users driving on a freeway, users walking in a shopping mall, that can be users in the park. There's a lot of use cases. There are applications that are crunching large amount of data, like all kinds of machine learning applications, and it is not economically viable to shuttle data from the source of the data all the way to public cloud. We all know how expensive is the traffic data transmission. Sometimes that's just legal compliancy type requirements. For some businesses, the data needs to be located in specific location or in specific country. There are many use cases. So my point here is cloud, it provides this amazing experience of making infrastructure work immediately, but we need this experience beyond the cloud. We need this experience everywhere, on-prem, at the edge, everywhere, especially when using Kubernetes and using other cloud-native tools. Most of these cloud-native application platforms, and Kubernetes especially, they are created with the infrastructure that dynamically responds to the needs of your application stack. When you run Kubernetes, it's very common that your Kubernetes cluster decide to scale to add more nodes. And that means that your VLANs, your load balancers, your routing, everything needs to automatically keep up with that. You cannot do this manually. Because these kind of changes happen every hour, and it's kind of common part of running Kubernetes. So we call this type of audience private cloud builders. So they either have our customers, our users are either companies that are building a greenfield infrastructure. They are either repatriating the cloud or going hybrid. So they want to replicate that cloud-like experience of automatic infrastructure operations. That's because that is part of their business. They are very DevOpsy type of organization. Like their business processes are very much tied into thinking about infrastructure like it is a cloud. And it is easier for them to build their new infrastructure using cloud-native technologies and use Netris for a networking part versus like trying to change all their development stack to like older stuff. That's one use case. And another use case is some of the users, they just have traditional infrastructure and they are willing to launch a Kubernetes cluster, like a brownfield type situation where their traditional infrastructure keeps operating the way it was operating last 30 years. And next to it, they built little cloud native cluster that is running Netris, and Netris cluster in that case is interconnected with their traditional networking, providing just.
So is that like a
connectivity.
move from like legacy apps to like new apps? Is that kind of like what they're doing there?
It's effort by IT teams to provide a foundation for the company to start moving from legacy apps to
So it's like a migration
cloud-native apps.
process then, right?
Yeah, that's a really interesting approach because I can see that both is a migration and kind of an augmentation. Whereas like you said, if there are traditional apps and traditional infrastructure that isn't going anywhere, you're not forcing an organization to do a rip and replace to be able to support what Netris can do to help scale with these new cloud-like apps on premises. They're able to migrate side by side or be able to run both infrastructures and connect them together. So that's really interesting. Is that pretty typical with what you see when customers come to you saying, hey, we need to be able to scale for these new age applications? Is it typically they start with new infrastructure in a separate cluster and use Netris to manage and onboard and operate all of that equipment?
We provide we provide what we call a sandbox, a test environment where Netris is pre-installed, and it sandbox comes with a little Kubernetes cluster and a few virtual machines, and with upstream connections. So users that are potentially interested in trying Netris, one way of trying Netris is that using sandbox. Of course they can install on-prem, but installing on-prem would require an environment. If they have environment, they are welcome to install Netris locally. That's free. But if they don't have environment, they are welcome to use some of the environments that we provide dynamically on our website. It's very easy. Just provide their name and email, and we immediately send them credentials, and they're ready to use. That way, they kind of learn and see if Netris is a fit for their use case. They validate their use case. They're welcome to join our Slack community and learn from other users or our engineers. And once they see the fit between their needs and Netris, and they are ready to proceed with the implementation, is just like you described. They set up a little cluster that is running Netris. They interconnect Netris with their existing network, if it's a brownfield scenario. And without pressure, one by one, without stress, they start moving whatever workloads make sense to move. For some companies, that's the migration process. For some companies, that's just part of plan. Some companies just want to be hybrid. They want to keep their standard thing, and they want to have their cloud native thing interliving.
Yeah, I was going to ask, do you foresee, how we have hybrid cloud, right? And I feel like that is more companies that are, would you say, mature companies, I guess. I feel like that's more of an option for those type of companies, whereas new companies, you were saying, jump on the cloud just out the gate kind of thing, because it's wonderful for the speed and being able to scale real quickly, right? So I feel like I come from one of those like mature companies, right? It's definitely we have our legacy stuff, and so kind of looking at it like a hybrid cloud. Would this be like a hybrid cloud on-prem essentially, but on a networking side of it?
Yeah, exactly. And legacy applications gonna be around for a while, and there's no problem with that. The only thing is that even large companies that happen to have this, happen to have infrastructure for many years, like 10, 20, 30 years, at some point they may want to have a private cloud, not legacy private cloud, but like cloud. So what makes cloud is VPC, because what makes cloud is that function of providing infrastructure services immediately, and that cannot work without VPC. Without VPC, every network product is operating with the switch ports or with some kind of network elements. Network. We have seen this SDN thing, right? Which was meant to kind of make network engineers' life easier and DevOps engineers' life easier, but it actually overcomplicated for both of them. It didn't make any easier for DevOps engineer, but it made things harder for network engineer. Like for many good network engineers, it's kind of hard to figure out even simple things with many SDN solutions. That's why I think that kind of SDN didn't stick around, and we also have seen this automation and IBN, intent-based networking type of products. Those things are making things better, but there comes this amplification, the amplifier factor. You put their wrong things, and they just amplify the wrong things, and just now even bigger stuff is blown up, right? What is fundamentally different in public cloud is that cloud is self-operating, so opinionated. You cannot kind of force cloud to change its kind of under the hood decision-making process. It's a higher level abstraction. That's why it's kind of more stable in terms of human error. But another important function is that the VPC that is running networking for the public cloud, that is tightly connected and integrated with the compute systems. Like when you request your bunch of virtual machines, whatever system provides you that virtual machine environment, that system communicates through API with the VPC, and it makes networking work automatically. Like there's no middleman telling, okay, network, please provide this ports into that service. No, that happens automatically. The exchange of IP information happens automatically. When your Kubernetes cluster decides to scale and launch more nodes, again, the networking underneath keeps up with that change automatically. That's what makes cloud. And that's why I'm saying even a company with a huge infrastructure that was around for many years may not necessarily need to rip off that old infrastructure, but may need to have a cloud, private cloud. And this is when they need a VPC provider, which is
so
Netris.
Like in a cloud scenario, you pretty much, you provide a subnet and then it does all the rest of like who gets which IP. You're not telling it, hey, you need to be on this VLAN. You're not doing any of that. You're just saying, I need this service, and by the way, I'm applying this security group to it, and within that security group, I'm allowing these connections, and then it just builds everything on the back end, right? So
yep, exactly.
let's pivot a little bit on that, because I think from my experience, sometimes obstructing that is a little bit of a turnoff for me because it's then I can't make the decisions and I can't do the tweaking and turning the nerd knobs. Have you seen people, like customers, that get frustrated with that, or is it pretty much people they buy into the whole it's the cloud experience but in a network?
So that's a great question, and we were very cautious about this during early days of planning and designing the product. So there are knobs that kind of make sense to touch, and there are knobs that we consider it's better to leave to software. Knobs that are like things that are around how you implement things, like how you organize default gateway on subnet, or how you organize your BGP timers between your switches, or how you kind of organize or how you apply ACLs to your BGP neighbors. Things like this are like, those are not making any difference to 90% of businesses. Maybe there's 10% which is different kind of corner case, that's fine. But for the case where the goal is to have a cloud native environment, run a Kubernetes cluster, it's not critical how exactly you configure your BGP in this mode or that mode, as long as the product that is making the decisions for you does things correctly. Now, whatever we configure, it's based on standard things. We don't have anything to hide. Although users don't really need to SSH on the switches and routers and make changes, but they are welcome to go there and review what we've configured. And when they review, they are like, this makes sense. This Netris is configuring things right. Like, I like that. Rarely, people don't agree with that, and they come to us, they come up with, hey, like, this is not right. And we're happy to hear that. We need that feedback. And there's a lot of places where we've improved the product based on feedback. We love feedback. We love learning together with the users, because the users they all are amazing engineers. There's a lot to learn from them.
So, I mean, my main question, I guess, is when the dev team is telling us that their application is slow, do I have a knob where I can speed her up?
Actually, yes, pretty much. So, look, when things are configured automatically by a single algorithm, not by 5 different algorithms, by just one algorithm, there's almost no room for conflicts. So that helps a lot. With that approach, you avoid a lot of issues. That's one. But still, there are places where we need human to turn that knobs. And for example, when it comes to peering with your upstream provider, like you still if you're doing that, if you're in that situation that you don't have your legacy network and you are connecting your Netris cluster directly to upstream provider, internet exchange points, you're receiving this full routing table, things like that, there's still a lot to do. Like, you as a network engineer, you have a lot to do there in terms of defining your strategy, doing your trace routes, your traffic engineering, playing with the BGP communities to like re-engineer your traffic. That's still around. We provide you with the good, tools and place to like turn a lot of knobs in places where it makes sense. But on the handoff side to your DevOps engineer, like your DevOps engineer not gonna ping you when they need a new VIP for load balancer, or they not gonna ping you when they deploy new Kubernetes cluster, because you have configured things insanely great for the DevOps engineer, and they are just happy to use that
Alex.
network.
I'm very much a traditional network engineer, and I'm starting, to come around on the aspect of abstraction, orchestration, and automation. But I'm going to get into the weeds with you a little bit. From a Netris perspective, do you have, when you're working with customers, do you have high-level guidelines for hardware choices of when they go to implement, or high-level topologies that they're leveraging in a data center? What do those aspects look like?
So we do a lot of testing on the hardware and our architecture. So we want to make sure that when users deploy things will work. We pay a lot of attention to customer success. And currently Netris supports few open networking operating systems. That's in terms of on switch side. So we support Cumulus Linux, we support just pure Ubuntu Linux with the switchdev driver, and we support Sonic. So whatever hardware can run any of these three operating systems, that's supported theoretically. But on top of that, we do a lot of testing, and we have there's list of hardware that we have validated, that we say we have run like thousands of tests on this and this models. You're welcome to use others. We will still support you, but like this is the hardware that went through testing. And over time, we will keep adding more and more hardware, and the part that runs on the hardware will go open source eventually, and hardware vendors will be able to adapt to new models that they have. And so the goal is to support more hardware eventually. But today, the goal is support to sufficient amount of hardware that our users will be able to put together clusters that are stable, super stable. Stability is critically important. So that's on the switching side, layer 2, layer 3 switching. On higher layers for routing, for border routing, for load balancing, for network address translation, for your VPN, those are functions that you still need in your private cloud, but your switches cannot do this, right? So what we have developed a data plane for Linux that is using DPDK acceleration and SmartNIC capabilities. So basically, our users they take a Linux machine with couple of CPUs with a lot of RAM. They install a SmartNIC card on that, a 100 gig SmartNIC card. They load Netris and just regular Linux. And that machine, just using open source standard tools, runs the border routing functionality with it can handle full routing table and forward packets at 100 gigs per second. It does your network address translation, source NAT, destination NAT. It learns sessions when it makes sense. It doesn't learn sessions when it doesn't make sense. It has that kind of understanding, and all that adds layer of optimization. It does your layer 4 load balancing and site-to-site VPN. All is based on standard open source tools, and everything is configured by Netris automatically. So switches together with that Linux machine, which we call SoftGate, like a software gateway, switches together with SoftGate and controlled by Netris all together provide that VPC type cloud-like functionality.
So let me ask this. Currently, when you go with, like Cisco or Juniper or any of those kind of vendors, right? You buy the hardware, and obviously it comes with their software on it, right? And so I think one thing that I have to think about differently is, and correct me if I'm wrong, but with your product, I would have to go out and get whichever switch that I need, and I have now a service or a service agreement with whichever X vendor that I got that switch from. But if I have issues with the hardware, I'm not calling Netris, right? I'm calling whatever that vendor is, and then Netris is more of the software that I'm putting on top of those switches, right?
Netris is software that you put on top of the switches. There's a switch, there's the operating system of the switch, and on top of operating system is Netris. Netris configures the operating system. In terms of support and troubleshooting, if something goes wrong, sometimes it's hard to tell immediately where the problem is. So whenever you bootstrap your network with Netris, we push our agent. We do the minimal configuration. So we start showing you the heartbeat from every network device, and we automatically start monitoring the device for like standard things like your power supplies, your fans, your temperature sensors, your like CPU load on your ports, laser signals. We try to pull out all the necessary information for monitoring, all the information that every network engineer would normally like to pull out. But we do this automatically, so you don't need to kind of worry about how do I pull that information. We just pull that information and show you on the dashboard. And if you have a hardware issue, oftentimes that information on our dashboard helps you. Like we may say, hey, there's a temperature issue and the fan is not spinning. Like that's a signal for you that you need to replace your fan. That's easier. That's the easy case, right? When we can show hardware issue through our monitoring. Sometimes there is a problem where like hard to tell. Like you don't know if it's a Netris bug, it's an operating system bug, it's a routing bug, or it's a hardware failure. Hard to tell. So we kind of feel responsible for the whole operation. And the way we approach to this is this. If you have any issue, you first reach out to Netris. Because our algorithm has configured your network, we we are kind of the best help to help to troubleshoot this down. And when you collect Netris tech info from your network, that collects not only Netris data, but also data about your operating system, about your hardware. And based on analysis of this data, we can tell like, hey, for example, there's a hardware issue. You may want to replace your hardware. And oftentimes your hardware is from one of our partners, and telling partner that these guys from Netris are saying it's because of hardware they have already validated. That's even sometimes even kind of helpful. Or if it's an operating system issue, we may tell you like, hey, there's a problem with the open source component that is part of your whole system. Here's a workaround. Take this workaround so your business doesn't suffer, but we're gonna go back and we're gonna work with with fixing that problem. We may end up working with engineers of partner, or if it's an open source thing, we may fix that and contribute back to upstream to the community of open source.
So basically, it's not going to be a bunch of finger pointing, right?
No, we want to be friend of network engineers. No, we're here to. This is created by network engineers. We want to help network engineers keep staying insanely great, keeping up with the progress of the world.
Keeping insanely great. I like that.
I've been calling Dan that for a long time now. So, yeah. Alex, we are getting towards the end of our time here. Is there anything more that you want to delve into that we haven't touched on yet? Yeah.
Take your time.
I'm thinking. I think you've. I think you did amazing job, and I just enjoyed this whole conversation. It just came like a casual conversation. Like at some point, I even felt like we're sitting in a bar, just three, network engineering dudes.
That is excellent to hear, because that is things. Dan's vision of this show in a nutshell. So
exactly, to a T.
So we really appreciate this time, Alex. Where can we point people that want to learn more about Netris?
Our website, netris.ai. Our documentation is published there. It's open for everyone. There's video demos that people can watch. We have this Slack community, Slack channel. Everyone are welcome to join our Slack. Not just users, but like it's a place where we speak about infrastructure. Like people are welcome to join. Twitter is a place where we share updates. Twitter and LinkedIn, but more Twitter.
Gotcha. Yeah, we can definitely put those in the show notes.
Well, thank you very much, Alex, for your time on this episode of The Art of Network Engineering. If you want to learn more about Netris, check out Netris AI. Netris.ai. And we will see you next time on The Art of Network Engineering. Take care now.
Hey everyone, this is AJ. If you like what you heard today, then make sure you subscribe to our podcast on your favorite podcatcher. Smash that bell icon to get notified of all of our future episodes. Also, follow us on Twitter and Instagram. We are at Art of NetEng. That's Art of NetEng. You can also find us on the web at artofnetworkengineering.com, where we post all of our show notes. You can read blog articles from the co-hosts and guests, and also a lot more news and info from the networking world. Thanks for listening.